Okay, problem number 11, same directions. It is in quadratic form, general form here, with a equal to 3, b equal to 4, and c equal to negative 3. Okay, so let's find the discriminant. B squared minus 4ac, 4 squared minus 4 times 3 times negative 3. When you use your calculator, I get 52. Okay, that is also positive, so once again we have two real solutions because the square root of 52 is not 52 is not a perfect square. We have irrational solutions. Okay, so we found the value of the discriminant, you found the nature of the roots, we now just need to solve. So the quadratic formula, okay, and now let's plug it in. So the opposite of b would be negative 4 plus or minus the square root of the discriminant, which is 52, all over 2 times a, which is 6. Okay, now we need to see whether or not we can simplify. Since the square root of 52 can be simplified, we need to simplify the problem. So over to the side, we'll break up the square root of 52, and it breaks up to 4 times 13. The square root of 4 comes out as 2, leave in the square root of 13. So this is negative 4 plus or minus 2 square root of 13 over 6. Well, do we need to simplify further? Well, if the outer three numbers are divisible by the same number, you must divide them. Since 2, 4, and 6 are all even, we can divide each by 2. So that would be negative 2 plus or minus 2 divided by 2 would be 1, and we don't write that leading 1 there, over 13, and 6 divided by 2 is 3. And that's your answer. Okay, same type of problem. We are going to first have to set this equal to 0, so 9x squared minus 12x, bring the negative 4 over. And now a is 9, b is negative 12, and c is 4. Okay, so let's find the discriminant. Okay, when I do this math here, I get 0. When the value of the discriminant is 0, that tells you you have one real solution and it's always going to be rational. Okay, so let's finish solving the problem. Okay, so x equals positive 12 plus or minus the square root of 0 all over 9 times 2, which is 18. Remember, the square root of 0 is just 0, so if I take 12 plus or minus 0, I just don't need to deal with that. I get 12 over 18 as my answer. It does simplify to 2/3. And you see that it is indeed one real number and it is rational. Okay, continuing on, it is in the proper form, so a is 2, b is negative 8, c is 5. Let's find the discriminant. Okay, when I do that math, I get the number of 24. Again, we have two real solutions because 24 is positive. 24 is not a perfect square, so they will be irrational. Let's solve. Okay, so x equals the opposite of b is positive 8 plus or minus the square root of 24 all over 2 times 2, which is 4. Can this be simplified? Well, look to the radical. It can be simplified, so we must simplify. So over to the side, the square root of 24 breaks down to 4 times 6, which becomes 2 square root of 6. So 8 plus or minus 2 square root of 6 over 4. Well, can we simplify any further? Well, 8, 2, and 4 are divisible by 2, so we must divide it. 4 plus or minus square root of 6 over 2. Okay, last quadratic formula problem. Recall that in all the other techniques, our leading coefficient for the x squared term must be positive, but that's not true with the quadratic formula. You can go ahead and have your a as negative, so we'll leave it negative here. So my A is -1, B is 4, and C is -13. So let's find the discriminant. Okay, when I calculate the discriminant, I get -36. Because this is negative, you will have two complex solutions. Complex means imaginary. Okay, that we don't ever say imaginary numbers are rational or irrational. That only applies to real numbers. So when it's complex solutions, it's simply too complex, or you could say too imaginary. What that means is your final answer will have an I in it. So let's solve. So x equals -4 plus or minus the square root of the discriminant all over 2 times a. Okay, we'll look to see if we can simplify. Well, yes, the radical must be simplified, and that's going to simplify to the I comes out, and the square root of 36 is 6, so that'll be 6i all over -2. And again, these numbers, -4, 6, and -2 are all divisible by the same number, and we never leave a negative in the denominator, so the number we're going to divide by is -2. So that gives me +2 plus or minus 3i over +1, which of course we don't need to write. And that's the answer.